It is good to be back. Let me check my audio and live stream real quick. I think I can hear myself. Yes, I hear the echo now. Perfect. Close that tab. Here we go. Welcome back, everyone. Super excited to kick off the Hugging Face study group. It's transformed into an NLP group, and that's what I'm referring it to. We took a bit of a pause, and I'll probably just take 2 minutes of yours to tell you what's been going on. So I spent some time, and I've been like spending a lot of time looking at different generative AI tools. You might have seen me share some funny chat gpt chats. Apart from that, I've also been looking a lot at stable diffusion and mid journey, and whenever you see me putting out a video, I always make sure it's really high quality and it's at the best, absolute best of my ability. So I've been looking at different ideas around chat gpt, open AI API, and things I could do around that, study groups I could create around that. So that's what's been happening, and you'll see them start happening really soon. So they'll just be a part of the NLP study group. If you're interested in that, I'll probably just launch that in a few weeks, maybe. I just want to make sure I have a really good grasp of it. And I'm also happy to show you my chat GPT chats. So if I've even managed to make it understand the Spanish culture and roast me in Spanish. I don't speak any Spanish, but if there are any speakers, I can show that as well. But now I'll get started. There's one more exciting announcement. So under the like button, you'll find a link to H2O AI's conference, which is happening in Bangalore. And if any of you are interested, I'll keep giving out coupons for attending every week. So just under the like button, it'll take you to this link. And I can't say much, but I'll say this much: with all of our Grandmaster power, we'll soon be putting something out in the LLM space really soon. So if that sounds exciting to you all, just engage in the chat and I'll keep picking random winners to give tickets to. Or if you want, you can also sign up. I think there'll be an online live stream, which will be free for everyone. Cool. So now let's jump into this, the thing that we're here for. So we'll be taking a look at Bloomberg GPT, which is a LLM for finance. That's the title of the paper, and I've literally copied it. For the record of the live stream, I won't be making any April 1 jokes today. So if you see me making any jokes, those are just simple jokes, and I'm not going the other extreme. So just to make it super clear. Although I was like very tempted to make a coffee joke or something like that, but not today. So the way I've structured this is, in the first about 5 minutes or so, I'll give you the summary in slide format, and after that, I'll pull up my not this. I'll pull up my Microsoft OneNote, and we'll take a look at the paper. So I'll actually also point different things out in the paper. So if you just want the summary, in first 5 minutes you can watch, and that should be good enough. And after that, I'll go into a bit of depth. So here's some context around the paper. No finance large language model has ever existed. To be honest, like very few large language models have existed in the history, and I think GPT-4 and Neo GPT are the most popular ones. Bloom is one of the other ones as well. So those are the three names. If you're not familiar with those, they're just LLMs. They're just model names, which happen to be used at really large scale and happen to have a lot of parameters. There are some closest efforts though. So again, all of this is from the paper, but some domain specific language models have been trained in the past. And these include BioBert, which is a BERT for biomedical domain, SciBERT, clinical BERT. And if you're paying attention, the reason there are so many BERTs is it's because at that time when these papers had just come out, when the bird paper had just come out, people started experimenting with this, and since then the experiments have sort of gone down. So that's why it took a minute for everything to pick back up. And if you've been paying attention, the palm architecture by Google, they've recently also released a medical palm variant of it. So that's a medical large language model. Here are a few more ones that I learned through the paper. There's bird tweet, medpalm. Galactica was trained exclusively on scientific data, and it combines the techniques from these two of sorts. And you can tell my slides aren't written by ChatGPT. That's because you can see the spellings aren't right. So I'm just pointing out that this is genuine human effort. Hey Carlo, we have a legend in the chat. Great to see you join the live stream. So the context is no financial language models, or for that fact, large language models have existed, and the authors have tackled that. Here are the highlights of the paper. It's not exactly 50-50 split, but I've simplified it. It's actually like 58 and 42%, but it's highlights. So please excuse that. They've used about 50% proprietary financial data. And what they've done is Bloomberg claims that since the 4 decades of their existence, they've been putting out high content financial data collection and news articles and all those things. So they've sort of taken that very high quality proprietary data. Some of it's available. If you want, you can purchase it through APIs. Some of it is already public through whatever blogs they've been putting out and other things. The rest is proprietary to them. And on top of that, they've also done some nice pre-processing. They've also had some annotators work on that. The rest, 50%, comes from general web crawled financial data. And we'll take a look at details of all of this. Right now, it's just highlights to remind you. The model is a 50 billion parameter model. And in the paper, they explain how they came up with all the hyperparameters. So I'm excited to get to that. And the total budget. So this is not the final model. This is the total computational budget, meaning that the entire project was designed to take about 1.3 million GPU hours on A100 compute. So if you look at any cloud provider, that basically means in terms of compute, it's about 1.5 million dollars of compute spent. For study, I prefer recorded video rather than live stream. What about you? I like live streaming because I get to interact with you all. And I like watching live streams as well. So, Ravi, if you want, you can watch the live stream later after it's done. They've used the unigram model tokenizer instead of subword tokenization. So, instead of greedy tokenization, they've used unigram modeling. And in the benchmarks, they've compared this against these three papers or these three architectures, and GPT-3 is somewhat, not exactly, and it's only compared where it's possible. So what they've done is they've run these three models at least locally, and they've compared it on the same benchmarks against all of that. Against not all of that, against Bloomberg GPT. So Bloomberg is compared against these three architectures. Here are some more architecture details. This is a 50 billion parameter model, as I mentioned earlier. The tokenizer has about 2 to the power 17 vocab size. And they've done some interesting things around how to reduce the vocab size. They've used alibi positional encoding. And I had actually looked that up. But if you want, you can read the paper. I didn't find it very useful. Again, most of the times you read these papers and it's a lot of knowledge to digest. But in a few weeks, all of this just becomes an API import. So if you want, like, there are different levels of understanding. I would suggest, if you want to know about alibi, probably skip that one. The architecture is heavily inspired by the Bloom architecture, and we'll see the details in a few minutes. Here are some training details. So I'm quite happy with the first point. I don't think the GPT-4 model even makes it clear, right? Does anyone know if it's even mentioned that it's a TensorFlow or PyTorch model? I don't think so, right? They only say Python, I think. So I'll answer your question, mic drop, after a few minutes. So at least it's good to see that that is mentioned. They used a PyTorch model. Here's the size of the tokens that they had used, and they had used about 512 GPUs. If you're curious, we'll get to that again. They had used the Adam W optimizer, learning rate warm up, and this is the first time I learned of it. Batch size warm up. I don't know if you all are familiar with this, but batch size warm up I think becomes relevant at large scales. So you start with a smaller batch size and then later increase the batch size. Same to learning rate warm up, but I guess it sort of makes sense at such a large uh, computational scale. So that's this is the first time I heard of batch size warm up. Some of the details around large scale modeling. So they had used SMP library by AWS for making things efficient across all of the clusters. While training, 4 copies of the models existed across different graphic cards or across the cluster subclusters. Is that a word? They had used simple techniques, so we know of these, and I think they also mentioned how they had created these, but they had also looked at fused kernels for increasing the throughput of the graphic cards. For evaluation, I mentioned the 3 architectures earlier, right? It's actually 4, but I'm only counting 3. So there's GPT Neo, there's Bloom, and I'm forgetting the fourth one. It's OPT. So GPT Neo X, OPT, and Bloom, it's compared against all of these. And simply put, on financial data, Bloomberg GPT outperforms everything else. On general tasks, it's second in class. So it comes second compared to other models. And generally, for broader tasks, so not financial tasks, it falls behind larger models. So they've compared it against the 4 models I mentioned, but when they compare it against Bloom's 170 billion one, I think that's a number. So Bloom's 170 billion parameter model, it falls behind in general tasks. But again, we have to keep in mind that this is a financial data specific model. So this is the high level overview. Now I'll switch screen sharing to the paper and I'll start highlighting different factors from there. And let me take a quick look at the chart. Carlo has kindly mentioned this paper, which I didn't know of. So FinBERT was a great early effort as a language model for finance, but he wouldn't call it a large language model. He says Bloomberg definitely seems like a big leap. By the way, if you don't know of Carlo, he's a bit of legend in the competitive data science and financial intersection. So I would highly suggest you follow his work. Whenever he shares anything, I always find it really useful, and I think he's doing some community sprints right now. Bharat is saying he's outside, so he'll catch up later. That's all right, Bharat. Do you think it would be better if they had used ngram tokenizers or other tokenizers? They might drop, they actually explain this inside the paper. So I think it's just on the third page. So we'll just get to it in a few minutes. Yeah. Thanks, Carlo. Carlo actually checked it for us. So GPT-4 doesn't even clarify if it's a PyTorch or TensorFlow model. I think we deserve to know at least that much, right? It'll be cool to know. I'm just curious. Like I don't have anything against TensorFlow. I personally like PyTorch, but I'd be curious. What's your opinion of ESG bird? I haven't looked at it, Ravi. Let me check it real quick. ESG bird, domain specific bird for text mining and sustainable investing. But again, I'm just looking at it right now. It looks like a bird model, right? And BERT is probably like much, much, much smaller compared to what we're looking at today. Cool. So let's dive into the paper. Please keep the chat going. I'll keep taking pauses and looking at that. So what I'm going to do now, just so you all know, just to be transparent, I've read the paper and I've made notes. So I'm going to point out interesting bits through the paper. It's about 40 pages of read. It's a very smooth read. So it's not like a lot of theorems or anything like that. To save your time, I'll just point out the interesting bits, and after that, if you want, you're of course welcome to read it. But my goal is to make sure you don't have to after this. So let me select the highlighter from here. Do you like the yellow color? Yeah, that looks okay enough. So here we start with the details. They say Bloomberg GPT is a 50 billion parameter model that's trained on wide range of financial data. We construct a 363 billion token data set, and later they tell you how they shrink down the vocab. Let me get this out of the way. This is, I think, one of the most key bits about their training. So it's also augmented with about 42% general purpose data sets. And this is general financial data. So it's not just general internet. They also make sure it's finance related data in there. Here's the table of content, and I'll be paying attention to some training details and also some of the evaluation, although the evaluation has been constructed in the financial domain. And I am not really an expert in that, so I'll just be glancing over a few details. To point out, the financial data sets are about 54% of the training, and the public data sets are about 48%. How does that math work out? That doesn't work, right? That's about 100. All right. I think what they've done later on is they've removed some of the common data sets. So after curating these, they found some overlap between the data sets and they removed that. I was just curious, how is this coming out to be like what 103%, right? So that's that's the reason why I was just curious. Um, Pretty cool to see what we'll be looking at later on. They also mention the training runs and they share different things that occur during that. So they mention obvious things like the spikes in error that you see when training such models and how did they tackle that. So I know they've not released the model, but I really picked this because I think it's one of the latest LLMs and we're still getting access to so much knowledge about how it was trained. So they start by saying GPT-3 showed the powerful benefits of training very large autoregressive large language models, and that have about 175 billion parameters. They said a notable example of behavior is the ability to perform tasks via few shot prompting, where a model can learn just from a few examples. And they say this ability improves well above random as we increase the size of large language models. Then they quote some other papers to say since then the LLM size has grown significantly. And they say fintech is a large and growing area within NLP techniques. Then they quote some other researches in this domain. They say financial LNP tasks have been constructed, which include sentiment analysis, named entity recognition, and news classification. Now, I'll point out a few things that were very curious to me. Right, so when you hear a sad news like 10,000 people were let go, that's negative, right? But in finance, that could be a positive sentiment because, again, not financial advice, I'm not an expert, but that could mean the stocks might go up or the market performance of that company or that organization might improve. Another example, so that was for sentiment analysis. What else is there? Yeah, sentiment analysis and news classification, named entity recognition. And this is also kind of hard, right? Like inside a simple headline where you're saying one particular organization bought another organization's stock, and there are always these weird acronyms, right? So you keep changing between them. So for example, Apple would be AAPL and Tesla would be TSLA, I think. I don't know of other stocks, those are the two ones I know. But that's also referring to an organization, but in this case it's the stock. So how are you differentiating between what is the entity referring to there, right? And they say while there are masked language models tuned for financial domain, no LLM has been tuned for evaluated or has been tuned for or evaluated in this domain. So they've like established the fact that Bloomberg GPT is really the first model. So they start by saying it's again a 50 billion model that supports a wide range of tasks within the financial industry. And they talk about the performance across different variety of tasks. They say they achieve this goal by constructing the largest domain specific data set yet. So there are two sides of Bloomberg GPT's good performance. The first is they've, of course, applied some really good techniques while training, and we'll just take a look at that. The other one, which I've been mentioning, is their strong data set. So, since they claim to be really good with financial information and coming up with all of that, news articles, furthermore, curating that, furthermore, having data sets that proprietary and unreleased, they think this is one of the secret sauces to it, and I think it might be true. And they say this draws on existing data creation, collection, and curation resources at Bloomberg. They further say that all of their teams have collected these documents over 40 years, and they have extensive archives of financial data over different ranges of topics. Now, if you think about it, 4 decades is not just 40 years. That includes some recession areas and some peak. I don't know what the opposite of recession is. What is it? I don't know. Maybe Carlo will correct me. Um, but I think that info is also captured there. And there's some discussion in the chat. I'm just quoting the example from the paper literally. So the example I mentioned where you let go of people and the stock bounces up, it's from the paper, and I'm just quoting the paper there. All right, let's see what else is worth highlighting. So their entire data set is about this big, 700 billion parameters, but they only use a portion of it. And they quote the papers that they're basing this off. Basically, it's a Bloom style model. So they do validate this on some LLM benchmarks, some open financial benchmarks, and then they've created their own internal benchmarks. Now, the third one, we just have to trust the paper for being true, because these are not going to be open sourced. First of all, the model is not going to be released. And secondly, the dataset isn't also going to be released. So the dataset that they've created, FinPile, again, I'll type it out in the chat. This dataset is not going to be released either. So we have to trust the word of the authors that they've properly evaluated, they've set up the validation correctly, and it's true. So the first thing they say is there are domain specific LLMs, but there are alternate approaches training a LLM on both domain specific and general data sources, which they also say has not been studied so far. Now, this results in the model being very well on the specific domain tasks or financial tasks, but also maintains strong performance on general purpose benchmarks. They say our training data is unusual for LLM training in that it includes a significant amount of curated and prepared data from reliable sources. Les is asking what happened to the study group. I mentioned in the first 2 minutes, Les. So if you have the time, please go back to the first 2 minutes and watch that. I've been working on creating more materials for generative AI and basically studying the OpenAI API. So that's what I've been up to. But if you think about it, this is quite powerful, right? And I was actually thinking about this a bit. So the reason why ChatGPT has been so successful is RLHF, and that's only happening because they get so much user interaction and they're getting so much high quality data through that through those interactions. I'm sure they're doing many other things no one really knows, but this curation aspect and having a higher quality data instead of just crawling the entire internet has seen much better performance. They also mentioned that the internet has all these toxicities, these biases, and they their their best guess assumption is it should be better than that. All right, let's move further. I'll keep checking my notes to make sure I'm not missing anything. um So someone had asked about, I think it was Mic Drop. Mic Drop had asked about the tokenizer, and it's sort of mentioned in this paragraph. Again, to recap, tokenizer is the critical step of transforming the text into a format suitable for the language model. This is, they say, overlooked for large language models because the vocab size becomes really, really big. We take a different approach and use a unigram model instead of greedy merge based subword tokenizers, since it saves probabilities, allowing for smarter tokenization at inference time. They again mention this later on as well, mic drop in a few sections, so you'll get a deeper view if you have more questions. So they mentioned some of the challenges. They say they benefited from the existing code that was a part of the Bloom effort, but they aren't going to release their code. They have said later in the paper that they will be releasing their training logs, which I think is still somewhat better than not publishing nothing. So we can expect that, and I assume that's going to somewhat speed up other developments, because what we miss out in these developments is what happened during the training. A lot of babysitting is required when training large language models or any models for that fact, right? Like you sometimes mess up very obvious things, or sometimes the training crashes. Sometimes you get out of memory errors even on 500 graphic cards, and you have to deal with that. And they have actually also given some insights onto what was happening while they were training it. So now they get to talking about FinPile, which is this proprietary dataset that I mentioned. They say it's a comprehensive dataset consisting of a range of English financial documents, including news, press releases, web scraped financial documents, and social media drawn from Bloomberg archives. I guess that's the benefit of being a leader in this space for really long, right? Again, I see some disagree. Sorry, I have to take a pause. I see some disagreement about the point I had shared. I was just quoting the paper about the how sentiment analysis can be different in financial domain. So I would request not to get very polarized about that. I was just quoting the paper about it. Cool. They say the resulting training corpus that is roughly half domain specific. Now again, they repeat things a fair amount of time over and over again, but I'm making sure I'm avoiding as much as possible of the repetition. What they further do is they deduplicate each data set. So they do mention where these data sets are coming from. I think one of these is from T5, others are from GPT Neo X models. And that's why you saw 103% earlier. So they do take the effort of deduplicating each data sets and removing the duplicates, because I'm sure there would be a lot of overlap. This actually is like a common criticism for GPT-4, that maybe it's just learning the evaluation, it's being checked on. So it's cool to see that they've actually taken an effort to deduplicate it. I'm sure OpenAI would have done something similar, but we don't know. um, they say Bloomberg analysts have curated financial documents that were either created internally or acquired from external sources. They utilize this collection to create FinPile. And all of this is basically data related to financial markets. Finally, they say they clean the data to remove markup, special formatting, and templates. Here they mention they cannot release FinPile, and they mention the reasons for that. But they do mention the dates range from 2007 to 2022. And that's actually cool to see. Oh, all right, that makes sense. So their entire data set spans over 4 decades, but the time-stamped version ranges from about, it contains about 15 years, and that does have the famous 2008 market recession. So they say for the web tokens, which is the general data, Bloomberg collects web content by identifying sites that contain financially relevant information. And they say this is already in FinPile. Its classifications are rough. So what they've done is they do a web crawl, which is focused on high quality websites that have financially relevant information, as opposed to a general purpose web crawl. And then they mention this for news, for filings. They mention some details about the US and how they've gone ahead and created those data sets, or how they've curated that. I'm skipping past that because again it's a bit repetitive. Fun fact, for the web scraping, they also scrape about 0.7% of Bloomberg authored articles. So they further include more articles from Bloomberg, which comes from outside. I think they might have co-authored this somewhere else. So now they talk about the public data sets. This one was used for training GPT Neo X, Neo J and Neo X. And they say there are three reasons for selecting this. First, because it has been used to train a LLM. And they say it has undergone data cleaning and pre-processing. And thirdly, because it has multiple domains and the diverse data will help the model generalize a bit. It's cool to see, right? Like I'm repeating a lot of facts, but it's also cool to see that they're iteratively going into their logics and reasons, right? So they're telling, hey, we selected this data set. They're not stopping there. They're telling us why they chose it. Later, they'll also tell how or why they chose the 50 billion number and where did that come from, because they could have gone with 500 billion, 1 billion, whatever, right? But where did that number come from? This dataset was used for training T5, which is also language model if you didn't know. Um, Thirdly, they use Wikipedia, and they say Pile and C4 already include Wikipedia, but it's somewhat out of date. So they say it could be beneficial to have the model up to date Wikipedia pages included. So for that, they included this up to July 1, 2022. I think that gives us some insights into how long this project took, right? If they like paused it on July, they might have been working since August, maybe. I don't know, August, October. No one really knows. So, mic drop again. Be ready for some more details that you were curious about. They say they chose the Unigram tokenizer instead of a greedy merge-based subword tokenizer such as byte pair encoding or word piece. based on the results from earlier works. And they're copying GPT-2's approach where they're treating the data as a sequence of bytes rather than Unicode characters. And they include all 256 bytes as tokens. They also mention how they're pre-processing even before tokenization and what steps they're taking there. Furthermore, they share some more details, and this is where we like really start getting into some juicy details, right? So they mention how they had done parallel tokenizer training, and they say that the Unigram tokenizer implementation is somewhat inefficient. It's actually really inefficient. So they tell us how that use a split and merge approach of splitting it into 22 domains and 256 chunks. These answers really don't sorry, these comments don't matter so much, right, unless you're training your own LLM. So for me, I'm just looking at, okay, we had a large vocab and we're shrinking it down and using it differently, and how are we processing that for speed ups. So they also mention we hierarchically merge the individual tokenizers by merging from each domain and then combining the resulting tokenizers. And they also mentioned how they've gone about this. So while merging, they've taken a weighted average of probabilities corresponding to tokens, and how they've calculated this. So that's also mentioned in the following sentence. They come up with a vocab of 2 to the power 17 tokens. And furthermore, they reduce the number by dropping tokens with smaller probabilities, and then they also renormalize. And after that, they also take more care to add some extra tokens. Is Unigram inefficient due to compute time or some other reasons? I guess because of the, like, first of all, its implementation is somewhat inefficient, especially at this scale. So I guess they've like done this parallel computation because of that. Like for most of our cases, we wouldn't even notice, right? Like for a document or like a bunch of documents. So I was just going to mention why I'm really highlighting all of these details is because it's cool to see that they've actually laid out all of these steps. And many companies are looking at training large language models, and this sort of then becomes a blueprint for all of us, right? Or all of the people who are interested in that. So now we get to some details about the architecture. And by the way, if you're looking at this, this is a summary of the hyperparameters and their values. So they've kindly shared the training tokens, the hardware, the learning rate, the final learning rate that use cosine decay, and even the parameters. So number of layers was 70, and you can glance over these details, but again, uh, it's just cool to see that, okay, these were the number of layers, these were the number of parameters. All right, cool. So this was the architecture. And what's going on here is SA refers to multi-head self-attention. LN is layer normalization. And FFN is a feed-forward network. Inside the feed-forward network, they're using GELU. And they're applying alibi positional encoding to the biases at self-attention. So whenever to all the attention heads where you have the bias component, so wherever you're doing plus B, they're applying positional encoding to that. So now if we look at this equation again, sorry, that's really not a visible color. Let's try this. Yep, that looks better. So the current hidden layer comes from two steps. First of all, it's the sum of the previous one and the previous one with a self attention layer after a normalization layer. The other addition also happens. So they're like two stems, if I may. And let me try to draw this if I can. So this would be HL, and there would be two components coming from previous layers. So the first one would be this, and the next one would be this, right? I don't know if that clarifies it, but just wanted to highlight that. The model has an additional layer normalization after token embeddings shown like so. And let me read from the subtext. So LNEM is the new component of embedding layer normalization. The second term includes two consecutive layer normalization. So you can see one is the layer normalization applied to embedding and just normal layer normalization. So I guess this becomes the first hidden layer of the model. So this is the architectural detail. Again, I'll quickly glance over it. There are 70 layers of decoder blocks which are defined like this, and every next layer is a sum of two components, the first one being this equation on top, the second one being this, and the first layer is defined like so. I'm just looking at the chart to make sure I explain this well. All right, I'll continue, but if you have questions, please do ask. So in this paragraph, they really explain how they came up with this number. So they said we have a total compute budget of 1.3 million GPU hours on 40 GB A100, so not the 80 GB for some reason. And this is we have adopted activation checkpointing. This cost them a little extra. And then there's something known as the chinchilla equations, which allow you to calculate um, what should be the ideal size of your parameters and tokens. So they say since we are data limited, we chose the largest model we can while ensuring that we can train on all our tokens and still leave 30% of the budget. This leads to 50 billion parameter model, which they say is chinchilla optimal for the compute budget. So they use this famous approach of calculating the parameters. They do claim that we could have increased the training data, but since FinPile is already so good, we didn't want to increase it further. So because of that, after plugging into the equations, after coming up with some clever calculation, after leaving some budget aside for whatever reasons, and doing a clever estimate, that's how they came up with the 50 billion parameter. Do you know what this current sort of positional encoding is? Is Alibi the current best? I am not aware of the current landscape, Kallu. Maybe someone else in the chat can mention. How did they decide on this architecture that they have to normalize the embedding? Did they experiment on the architecture? Great question, Mike Drop. Let's read the paragraph because I'm also not too sure. The input token, I'm reading right here. So I'm reading this paragraph. The input token to linear mapping. So they're following an older paper. I think this is referring to Bloom. I might be wrong about that. Or maybe Palm. I think this might be Palm. And Detmers would be 8-bit Adam, I believe. So they're following the approach from older papers. That would be my guess. I need to check what these papers are. We'll probably after, but I need to scroll a lot and it's disorienting. So I think I'm satisfied with that answer. They just looked at older papers and based on that they decided to go with it. Cool. They also mentioned we want the dimensions to be multiples of 8 because we want to achieve higher performance in tensor core optimizations. For that reason, they settled on 40 heads, each having this dimension, resulting in this number, which happens to be a multiple of 8. So this is the complete derivation of how did they come up with this number. Now they share some details. The first, which makes I think at least me happy, which is it's a PyTorch model trained with the standard left to right causal not casual. I mentioned casual in a previous live stream and everyone just ate me alive. So I'm not going to repeat the mistake. Causal language modeling objective. And they're using 2048 tokens to maximize GPU utilization. Let's see if there are any other details. No. So next they mentioned they had used RMW optimizer. And in the following paragraphs, they also mentioned the different hyperparameters they had used for this case. They also mentioned that they use learning rate warm up for first 1800 steps. And they also reduce the learning rate a bit. So the final learning rate is 6 in x6. They also mentioned the model parameters are initialized from a normal distribution, like so. You can read through it. And following Megatron, they also rescale the standard deviation and output layer using this formula. Furthermore, they also use FP16. I don't know when FP16 does not make sense. So I think it's really good for all cases, right? Like maybe FP4 and int4 might not be ideal. Like I know you need that to run a large language model on your MacBook, but for training, FP16 is a no-brainer. Maybe FP8 is not, but at least I think FP16 is always good. Carlo is kindly mentioning that alibi is SOTA for positional encodings. Sorry. There was an experiment where models with positional encoding were reasonable, but nowhere near the performance of alibi. Thanks, Carlo. Thanks for that answer. So, see, someone was asking earlier, why do I live stream? This is because I also get to learn with you all. And I'm also putting out very polished videos, if you've noticed, but I think I'll keep live streaming in parallel as well. So it's a bit of parallel computation for me, but that's all right. They also mentioned some training instability. So they say LLM optimization is convex optimization over really incredible non-convex loss surface. And they say Palm, so they're quoting Palm. They found that loss spiked roughly 20 times while training Palm in the original paper, even though they were using gradient clipping. So how did they tackle this? What they did was they restarted training from a checkpoint and they skipped a few batches. They've also shared the hypothesis behind why this was helpful. So next they share some details about the GPUs they had used, which I'm going to skip. We've covered that. And here's another one. These are things we commonly overlook, right? Which is when you have so many clusters, what's the most optimized way to um, communicate between that? Someone is saying do code with coffee. I'll have. Now you're triggering me. So they mentioned Amazon FSX for Lustre is the best way of doing this quick data access. For large scale optimization, now they mentioned some details around how they had taken care of making sure this works well with the large scale model that it is. They use the proprietary SMP library from AWS, which enables automatic distribution of large models. And then they give some benchmarks around how they had improved. These don't matter. Um, they also mentioned zero shards, the training state across a group of GPUs. And then they mentioned that they had a model across 128 GPUs and 4 copies of it exist. They mentioned some more fine details, which I can skip over. But if you're curious, you can read about it. I guess this just becomes relevant when you're dealing with really large scale models. The final one that's worth covering is fused kernels. So they say another possibility for optimization is combining several operations into a single GPU operation. Uh, I was trying to think of a simple analogy. This is like torch.compile on very large scale. So fusing those computations on the GPU just makes it a little faster to compute. And in the last sentence, I mentioned that they see 4 to 5 teraflops improvement. And it also helps avoid out of memory errors. It's curious to see that you can still get out of memory errors at this scale, right? So here's a learning curve of the model, and they've zoomed in at this step, which looks relatively smooth. But later, just in the like next page, they mentioned that they had to like restart the training at these points. So what they did was they reduced the learning rate at the orange layer. I'm zooming in a bit more to make it clear. And for the green part, which here which looks fairly flat, but as you can see, it's like not exactly flat. They had added dropout, and for the red, they had further reduced, sorry, increased the learning rate. No, that would be reduced. I'm just getting confused. That would be reduced. So they actually changed the training hyperparameters across the training. Cool. Now we get to evaluation. So they mentioned two things here, that Bloomberg GPT is evaluated on two categories: finance specific and general purpose. I mentioned earlier it's based on finance, okay ish on general purpose tasks. For the financial one, they directly test its ability on Bloomberg's tasks of interest, where they've drawn data from internal high quality evaluation sets. So that obviously means that we'll not get to know much about these data sets since it's proprietary, obviously, as it seems. After this, they mentioned the models that they have compared it against and the different tasks. I think it's not worth going into a lot of details around these. But let me know if you guys are curious. I'm just going to glance over all of these details. So one thing they clarify here is every task is tested via standard prompting without any parameter changes to the other models or without any chain of thought prompting or task description. The number of few shot examples depends on the tasks, and they've included these details. So basically, what they're trying to say is when we've compared these models, we've kept them as original to the existence as they could be. So they're like really tried to keep it untouched. And I guess you could also like for large language models with chain of thought prompting, you could change how they behave, right? So like you could also spoil that a little while you're doing evaluation. So they do clarify that they've not done any changes there. So this figure shows that Bloomberg GPT is outperforming all other models. And they say this was expected, but we're still doing it as a sanity check. So you can just look at this, but I'll now scroll past it. If you want, you can pause and look at it. Um, this is bits per byte on a holdout test set of each data type in the fin pile. Lower is better. Um, Now I'll come to the part that sort of upset the chart a little, which was financial tasks. And they say NLP tasks most often considered in finance are also common in broader domains. But they say take the example of sentiment analysis, where a headline such as "company to cut 10,000 jobs" is a negative sentiment, but can at times be considered positive for financial sentiment towards the company. as it might result in the stock price or investor confidence increasing. You all have already discussed this, but this is where it stemmed from. After this, they share more details around external financial data where they evaluate these. They mention the names of the data sets. I sadly don't recognize them. They've also mentioned different tasks. So, headline classification, which is a binary classification where a news headline in gold commodity includes certain information. After that, there's NER, where they give the standard example that it's quite confusing between stock names and company names, and that can get tricky for financial information. So, no further details to be highlighted from here. They further do some more internal task of sentiment analysis. So, they say here, we consider aspect specific sentiment analysis, and all the data sets were in English. For that, they had created a team of three annotators, and after that, further evaluated the data set. So they've like done this three levels of evaluation on their own curated financial FinPile dataset. After that, they check it on general purpose tasks. The third is they've like hired annotators, created annotations, and done some tests. Rohit is saying I decided to follow this paper over a week, but it's better getting an in depth. I hope I do justice to that, to your 1 hour in that case. Cool. I'm just glancing over my notes if I have to anything to highlight. Again, ideally, I would want to memorize this, but my context length is definitely shorter than 2000 tokens. So, or at least the vocab size of this paper. So I always have my notes handy to double check. Cool. Scrolling further, they mention later that how they've evaluated this on general purpose tasks, and they start with big bench hard, which I think is a more recent evaluation technique. I am again foreign to these, so maybe you all know better, but this is the first time I'm reading of all of these benchmarks. They show that Bloomberg GPT falls behind larger models, but it is best performing among similarly sized models. Its performance is close to Bloom 176B or GPT Neo X. One thing worth highlighting here, Bloom model was not just trained on English, it also had general data from other languages. So I'm sure that if they compare the Bloomberg model to foreign languages, it wouldn't perform well at all, right? Because they say it's just English. Uh, so in that case, like the extra parameters here, I'm sure they've like captured some details about foreign languages as well. Just wanted to highlight that because I think that was a bit missing in the context. Now let's get to the summary. I'm skipping past all of these benchmarks. So you can read through that. I guess since we don't really have access to the model, we can only see like how well did it perform. But the highlight covers what I wanted to. So here's the summary. Their goal for Bloomberg was to be best in class for financial tasks, and they included general data to support the training. The model has still attained abilities on general purpose data that exceeds similarly sized models. This is, I would say, somewhat true, not always true. Um, Next, they share some qualitative samples. So they also did a fourth layer of evaluation where they checked the generation of Bloomberg query languages. This was pretty cool to see. So it was like a normal uh, query about financial data, which would like be really cool for regular people, right? Now, I don't know what they're planning to do. Maybe they release this as an API. Maybe they create a chat interface for all of us. That would be cool, just to like, I guess, I'm guessing, for like people working in finance to interact with this model, or just have it as a benchmark, or just have it as a second opinion. We'll see if they do that. There's like no mention of it at all. But they do compare it for suggestion of headlines, generation of Bloomberg query language, and financial question answering. And they say this like performs quite well here. So they say Bloomberg GPT correctly identifies, let's say, CEOs. Neo X does not. Flan fight uh, extra large completely fails. Cool. I don't think there's much more highlight towards highlighting here, so I'm scrolling a bit further ahead. Again, they've like repeated a lot of things, but they've like added more depth. So maybe that's common in financial domain. So you can read through it, but a lot of the details are repeated here and there. Finally, they again mic drop. You asked once, but I'm answering your question the fourth time. They say tokenization and vocab plays a critical role. Byte pair encoding learns a greedy bottom up vocab by repeatedly merging the most frequent sentence pairs. We looked at this in the second live stream of the playlist. So if you've been watching the study group like Les and other people and Bharat have, you know this. Um, but byte pair encoding follows this approach. Word piece also runs bottom up vocab. In contrast to these, Unigram learns a top down, so it's the opposite. By first initializing a large vocab and repeatedly discarding those items that increase loss. So here's another mention of the choice. Finally, they mention here very concretely that first of all, their clients are eager to adopt SOTA technology to provide natural language applications to financial community. They've developed a rigorous risk and testing assessment, which has they've mentioned a lot of checks in places. They say that toxicity and bias are extremely taken care of, and they're quite curious if using FinPile, which has like lesser such examples, reduces this case. So that is like a next step for them, that they're going to evaluate this on that. This architecture on toxicity, this on that, this architecture on toxicity. So again, final conclusion. Their model contributes to ongoing dialogue of ways of training a domain specific model. Their strategy of mixing domain specific and general purpose model results in a model that balances both domains and is really good in finance. So that was the achievement that they've completed. Finally, they mentioned they have some directions that they're going to pursue. And the first is fine tuning, which has yielded significant improvements, and they plan to consider fine tuning their model. The second one is by training data on FinPile, they're selecting data that might be less toxic. So they're curious to see that and how does that perform. And finally, they'll see how their tokenization strategy changes the resulting model. So I don't know when they'll come up with a follow-up model. They're going to release the training logs of this. We can expect that, but the model and the data set aren't going to be published. So let me switch screen sharing again to wrap up. So if we fine tune ChatGPT OpenAI model on custom finance data, we should expect that it will be our par. It could be better. We never know, right? So like no one has done these experiments, right? I'm just looking at the other charts, but that's also curious to see, right? Like so, what they've done is they've gone the other way where they like first just trained on finance data and also general data, and if you like fine tune, I'm guessing again here because no one really knows. But if you fine tune GPT-4, which is like again trained on this entire internet and somewhat proprietary data sets, and then you take that and fine tune it to finance, that could be better, I'm guessing, because that's what we do for like regular models, right? So if you take a ResNet 18, ResNet 34, that's the ImageNet model, internet, fine tuned to your particular data set, let's say satellite images or whatever. And that's the approach we take. So I'm guessing in that case it could outperform. Hypothesizing here, not an expert in LLMs. This I think was the like first paper I read in depth. We'll see though. Maybe GPT-5 will have like a financial um, plugin, or maybe the current one will have a financial plugin. So I wanted to explain this paper and also highlight the juicy bits. I hope that's what I was able to get across. If you all have some more time to spend around this, I would suggest this homework where you can share the summary of the paper. So I think writing what you have learned and sharing it with the world is like a really strong signal. If you do that, please consider tagging me. I would love to amplify your work and also love to highlight it in the next live stream. I plan to continue these live streams, and for someone who's been mentioning they're curious to like see more stuff, I will be showing how to properly use the OpenAI API. I've been learning that myself along with LangChain, which I've just started learning. So there are all of these frameworks that you can play with, and I've been like looking at different ideas you can create out of that. Also, really like discarding a lot of ideas, which has been heartbreaking, but that's where I've been spending the time. So that will happen in a few weeks. You can reach out to me if you're interested in collaborating on that. In all chai things, this will also be like open source and made available. um, One thing I'll mention is remember to take breaks if you like following this crazy development speed where like I saw this tweet that had the number of things, major things shipped, and like it's impossible to even read through that screenshot because it's just so damn long. So it's like I think it's AI summer, which is really great for all of us. But if you're feeling overwhelmed, which I'm also at some points, all of these things are going to stay. I'll, if not me, someone better than me will also be making content explaining all of this. So we'll get to the info. If you're not keeping on top of it, I guess that's completely fine. It's like almost impossible now, and especially if you're like trying to be on top of text to video, stable diffusion, generative AI models while having other things in life going on. That's like completely, that's a challenge. You should write a paper on that, and then that will be the most cited paper of the year. But we'll wrap up on that bit of advice. Thanks for watching. If you all have any questions, I'll stick around for 30 seconds. Otherwise, I'll read your comments. And for the chat, I promised I'll give out a few coupons. So Rohit, if you're watching this still, please reach out to me anywhere. I'd love to give out a coupon to H2O's conference to you. Carlo, I don't think you'll come to India. If you'll be in India, I can give you a coupon, but the live stream should be free. And mic drop, I'd also love to share a coupon with you. So please do reach out if you'd like to take that. The coupon is for H2O's conference. It's under the like button. Cool. Thanks everyone for watching. We'll meet again next Saturday. Alu Explains was asking what's my caggling advice. I'm doing Kaggle Top Solutions every Sunday. Join that if you're interested. I'm also thinking, I'll show this since everyone's here. So let me show this. A cool hack that I was trying. What I've done is I've fed ChatGPT different top solutions and asking it for approaches. So that was another approach I was trying. Let me find that chart. I have like too many charts. I just talk to an AI these days. But here you can see. So what I've done is I fed it a lot of older solutions, and then I asked it to come up with a new solution based on these approaches. So you can expect something along this. If you want to collaborate, reach out. But you'll see ChatGPT in the Kaggle live streams as well, and surprisingly, it works quite well in this. So uh, I was honestly surprised. You can expect that as well. But just join those live streams, or I'll see you next Saturday. Thanks for watching, everyone.